Welcome, ladies and gentlemen. So what I'd like to do is show you how to find the area as well as the perimeter of a triangle. So to do this, the main important thing that we first need to do is go ahead and remember what the formula is for a triangle to find the area. So the area is basically going to be 1/2 base times height. Now, you might have previously understood the area of a triangle being length times width, and that's perfectly fine. But in geometry, we like to use this base and height. And you can basically think of the base as going to be, if we were going to take these two-dimensional figures and then put them on a desk, the base is going to be what is going to be touching the ground. So what is going to be kind of holding it up. So as you see in this kind of example, you can see that the base would be 4, right? Now, you could rearrange this, which we'll talk about here in a second. But right there, we could have the base being 4. And it doesn't matter, even if you tilted that and the base was 3. It doesn't matter. You're doing base times height. So that's the same as 3 times 4 is 4 times 3. You're going to get the same answer. So therefore, to find the area in this example, all I'm simply going to do is do 1/2. I'm going to call the base 4 and the height 3. And then I'll just simply multiply those. 4 times 3 is going to be 12 times 1/2 is going to be 6 meters squared. Now remember, area is kind of measuring like that space that's inside of that triangle. And since it's going to be a two-dimensional space, it's going to be meters squared. Now, as far as the perimeter goes, you could do formula for this, and a lot of times for quadrilaterals we have the formula. But basically, the perimeter is going to be the distance around the figure. So the only problem is we don't know what this hypotenuse is of this right triangle. So there's a couple ways we could do this. If you remember, we could use Pythagorean Theorem. If we were going to say this was a, this was b, and this is c, Pythagorean Theorem says a squared plus b squared equals c squared. Or we could also understand that this is a Pythagorean triple, and probably the most common Pythagorean triple that you are going to be able to see. So you could use Pythagorean Theorem to figure that out, or what we'd be able to easily see, understanding Pythagorean triple, that length is going to be 5. So therefore, to find the perimeter, all I'm going to do is add all these up. So I have 3 plus 4 plus 5 is going to be 12 meters. So my perimeter is equal to 12 meters. Now again, that's one-dimensional space, so therefore it's just going to be meters. All right, so in the next one, we kind of have a little bit of an issue here, because we have the base, right? But we don't have the height. The height is going to be directly perpendicular to our base. So this would be an example where we'd actually want to rotate our triangle so we can get a different base. So I could either do it anyway, but I'm going to rotate so it's my 10 meters is on the base. So when 10 is at the base, 10 centimeters is at the base, this length would be 24 centimeters, and this length would be 26 centimeters. Now I can identify that 10 centimeters is my base, and 24 centimeters is my height. That's very, very important for you to be able to understand that we can rotate these figures. If it's not very obvious what the height and base is, then we can rotate them. So the area is going to be 10 centimeters times 24 centimeters, which equals 240 centimeters squared. The perimeter is just going to be the addition of all of them. 24 plus 26 is going to be 50, plus 10 is going to be 60 centimeters. So again, you're just adding up all the lengths. And the next one, this one doesn't look very good, but there's actually multiple different ways to do this. Back on this one, and actually, I didn't even realize. Yeah, you could have done those for that. I was trying to keep it simple, but because the one thing I wanted to kind of show you in this is a lot of times we're not always going to have right triangles. Okay, so if I was going to rewrite this, a lot of times, now the only reason why I showed all these side lengths was to find the perimeter. But I just want to show you, if you have a triangle and you have the base here, which is 6. So if I just rotate this for here 6, and then my height is 2, I don't really care about what those two side lengths of the triangle are. Those aren't the height of the triangle. The height is how far is it from the bottom to the top. So I don't really care about these two sides. They're given to us because I'm going to find the perimeter. But I just want to go through. If I want to find the area of this triangle, all I'm simply going to do is do 1/2. Oops, did I multiply by 1/2 here? I did not. I forgot. So therefore, that's 240. So that's 120 centimeters squared. That's why you write the formula and then solve it. And I got lazy, and because I was trying to show in space. So just be very careful with that. I apologize. That's 1/2 base times height. So over here, I have 1/2. My base is 6 times my height, which is 2. And I'm sorry, I should be writing in my units as well. I'm getting lazy here. 2 inches. So therefore, that's just going to multiply to 6 inches squared. 6 times 2 is 12, and then times 1/2 is going to be back to 6. The perimeter, in this case, is again just going to be adding all in. So we don't really care about this height value. Now that was just helpful for the area. But for the perimeter, it's just going to be the distance around. And you can kind of think of a lot of times perimeter would be like fencing. How much does it take to go around? If you're going to draw a line around them, how long is that? Or if you're going to take string and wrap that around the figure, how much is that? So you can do 6, 4, which would be 10, plus 3 is 13. 13 inches. And just remember that perimeter is in one-dimensional space as area is in two-dimensional space. So it's not going to be squared on. All right, and this last one is one that I can say gets so many students. Is going to be in another oblique triangle. So here is an oblique triangle, but I gave you the height. Well, the height was inside of the triangle. And so for some reason, that helps out of students. But a lot of times, if I give you an oblique triangle where the height is outside the triangle, a lot of students get really confused. And they want to call the height 13 or 12. But in reality, think about this. Is like, here's the building, right? These triangles, these don't tell you how tall those go up to the top of the building. They just say how far of a distance it is from the base to the top of the building. But if I really want to know how high that is up, I want to look at directly from the ground to the top of the building. Like, how high is that? And this example, you can say that that's 10 feet. So if I wanted to find the area of this triangle, I'm going to use, again, 1/2 base, which is 1 foot, times 10 feet. OK? So now 10 foot times 1 foot is just 10 feet times 1/2. That's going to equal 5 feet squared. However, if I want to find the perimeter, then I do care about these two side lengths as well as this base. So that's going to be 13 feet plus 1 foot plus 10 feet. 14, so that's going to be 24 feet. So there you go, ladies and gentlemen. That is how you find the area as well as the perimeter of a triangle. Thanks.